Welcome everyone. My name is Fernando, as I said. I'm here with my colleague Pedro from the Matrikon technical team. Well, thank you very much for joining this webinar, this live training about the MatrikonOPC Tunneller UA. So the idea of this webinar is to learn how to get the most out of your MatrikonOPC Tunneller. Either if you know the software, either if you know the MatrikonOPC Tunneller, you will, well, if you know it, you will learn all the new functionalities the software has, or how to get the most out of your tunneler. If you don't know it, you will also learn what connectivity challenges the MatrikonOPC Tunneller solves. All right, at the end, it's an application that allows you to move data to communicate OPC applications. So you will learn also what connectivity challenges the MatrikonOPC Tunneller solves. All right, so let's start with the presentation. During the presentation, you can write all your questions in the chat. My colleague Pedro, he will be helping me with the answering your questions, but either way, at the end, we will review all of them. All right, if you have any questions during my presentation, you can write them in the chat, and at the end, we will make a comment about it. All right, so during this training, this is the overview. All right, first we will review quickly. All right, most of you already know what is the OPC technology, but it's good to have like a quick review of the 2-3 minutes of what is the OPC technology. All right, then we will talk about the MatrikonOPC, sorry, the OPC classic technology, because the tunneler is a software that allows you to communicate OPC applications. So first we will talk about the OPC classic technology. Then we will talk about the limitations, right? This is a technology that was created in 1995. So we will talk about the limitations that the OPC classic technology has. We will talk about the relationship with Windows, okay? Because this is very important in order to understand exactly what the MatrikonOPC Tunneller does. We will make a demo, all right? The idea is not only to show you what the software does, what the software solves. Also, we want to show you a live demo. My colleague Pedro here will help me with that. We have 2 virtual machines, and we will play with the software. So, well, if you are familiar with the tunneler, it will be very useful. If you don't, you will have an idea of how easy you can configure it. Then we will talk about the OPC UA. All right, so this is the evolution of the OPC Classic. It solves many of the limitations the OPC Classic technology has, and we want you also to understand that the new features of the MatrikonOPC Tunneller are related to OPC UA. All right, so we will make also a demo about that, how we can migrate OPC Classic architectures to OPC UA, or how we can work with hybrid architectures which involve OPC Classic and OPC UA. All right, so let's start. As I said, if you have any questions, write them on the chat. All right, so let's quickly review what is OPC. All right, here in this slide, you can see below all the devices, all the data sources that we can find in the industrial or in industrial environments. We have PLCs, we have the distributed control systems or DCS, we have scales, databases. All these devices below, they are data sources. So we want to get data from those devices into applications where we can visualize data, where we can log data, where we can make reports, where we can make trends. So all the applications on top are applications that need some data, okay? So the idea of the OPC technology, it was created by the main automation vendors, Siemens, Rockwell, Honeywell, ABB. They all came together and they say that let's create a standard or a way to communicate our devices without taking care who is the vendor of the data source, all right? Because all those devices that appears below, the PLCs, the DCS, all of them, they speak a different communication protocol depending who is the vendor, all right? There are some PLCs that speak proprietary protocols or others that speak open protocols like Modbus, all right? But each of them speak a different language, all right? So if we want to communicate a Siemens PLC, for example, and we want to read that information into an SCADA, we need the driver in the SCADA that understands the Siemens protocol. The same happens with Allen Bradley, the same happens with Omron, and so on. Right? So at the beginning, before the OPC technology, the customers or the industry were forced to be tied to a vendor. All right, if I had the Siemens PLC, I had to use the Siemens SCADA. If I have the ABB PLC, I had to use the ABB SCADA. All right, so because of this situation, the main automation vendors, they came together and they say, okay, let's try to solve this. So if I face a customer who has PLCs from Allen Bradley, I can either sell my SCADA from, I don't know, from inductive automation. All right, so they came together and they say, let's create a way we can, our devices and applications, they can interface with each other. And they created the OPC technology. All right, this was back in 1995. They created a standard. They created a standard in order to allow you the communication between all these data sources and these software applications without taking care who is the vendor. Okay, so let's review quickly what is the architecture in OPC. This is very useful because this applies not only to OPC Classic, applies also to OPC UA. All right, OPC is a technology that is a client and server architecture. All right, so it could be any architecture in OPC will have a client asking for data, will have a server, an OPC server, translating the petition, and it will have a data source. All right, so the way it works is that the OPC client requests the data to the OPC server, the OPC server asks for the data to the data source, and then the OPC server answers with the information to the OPC client. So all those applications that we were seeing on top, all the SCADA systems, the ERPs, the MES system, those applications, they want to be able to connect with as many devices as they want because they want to sell more licenses. So all those applications, they included an OPC client into their drivers, all right? If they have an OPC client into their drivers, if the SCADA has an OPC client, they will be able to connect to any OPC server, right? And the OPC server it works as a translator. It translates from the protocol of the data source into OPC, right? So every time we have an OPC architecture, either if we are talking about OPC Classic or OPC UA, we will have something like this: an OPC client asking for the data to the OPC server, the OPC server translating the petition to the data source. This could be a PLC, this could be a DCS, or this could be any data source. The PLC answers with the information to the OPC server, and the OPC server sends the data in the OPC format to the OPC client. All right, this is the basic architecture, and this applies to OPC Classic and to OPC UA. All right, so let's talk about OPC Classic. As we said, this is a technology that was created back in 1995. All right, it's a technology that has more than 30 years. It was created to access multiple data sources, allows you a device-to-device communication. If you want to move data from PLC from one brand into PLC and move that data to PLC from another brand, this is something that you can do with the OPC Classic. It supports redundancy, all right? When we have critical infrastructures, with the OPC Classic, we can implement redundant architectures, all right? We can do some management with the data. This is what the OPC Classic solves, all right? As I said, it's a technology that was created in order to make it easier, the integration between the different devices without taking care who is the vendor. But of course, it's a technology with more than 30 years. So of course, it has some limitations. One limitation is that in the moment the OPC Classic technology was created, instead of creating their own technology or their own stack to communicate the two applications, they use an existing technology, which is the COM and DCOM technology from Microsoft. All right. So the OPC Classic is tied to this technology. When we communicate, this is something that we will review during this webinar. When we communicate an OPC Classic server with an OPC Classic client, we are using the COM and DCOM technology of Microsoft. Right? This is a limitation because we are only tied to Windows environments. That's why we say it's platform dependent. Right? This We will see later that this changes with the OPC UA. The security. The security in the OPC Classic is based on the security of the Windows on the operating system. So at the end, when you communicate an OPC server with an OPC client, the security is based in the Windows user, right? This is also a limitation because, well, more than 30 years ago, this was very useful and this was enough to make secure communications. But as we know, today we have very hard cybersecurity standards, and well, for this era, of course, this is not the best way to establish secure communication, right? And also limitation, we won't go into this in this webinar, but just for you to know, a limitation is that the OPC Classic has a very simple information model of the data, all right? In the OPC Classic, you have an structure, which is the name of the tag, the value, the quality, and the timestamp, all right? This is for every OPC server and client. With the OPC UA, we will see that we can make more complex data modeling in the communication. Okay. Perfect. So, as we say, OPC Classic, one of the limitations is they didn't, in the moment it was created, they didn't develop their own technology to communicate the two software applications. So that's why they use an existing technology, which is the COM and DCOM technology of Windows. All right. So just for you to explain you quickly, most of you probably already know, when we talk about COM or COM, we are talking about applications running under the same computer. Okay, when you copy something from Word into Excel, for example, you are using the COM, the technology of Microsoft, to communicate two software applications. When the applications are running on different computers, we call them DCOM. Okay, so this is the technology that OPC uses to communicate, and an OPC server and an OPC client are Windows applications. So when you have them on the same computer, you are using COM. When you have them on different computers, you are using the DCOM, right? Perfect. So this is our representation. It's a graphic that represents how is a local connection, which means when I have the OPC server and an OPC client running on the same computer. So in this case, we use the COM, right? Like COM. So the OPC server is in the same computer with the OPC client, so they communicate through the COM. In this case, normally we don't have any issues or we don't have any incidents with the communication because both applications normally are running under the same Windows user, they have the same permissions. So typically when we have the OPC server and the OPC client, again, we are talking about OPC Classic, when we have them on the same computer, we don't have any issues and we can easily connect the OPC Classic with the OPC server. The limitation, we start to see the limitations when they are running on different computers, which is this case. What happens when I have the OPC server running in one computer, because it's the OPC server of my DCS, I don't know, Emerson Delta V, ABB 800XA, Siemens C3000. What happens when my OPC server is in one computer and the OPC Classic application, the client, the SCADA, the ERP, the historian is running in another computer? So in that case, we need to configure the DCOM, right? So, for example, we always give this example because we teach an OPC training of 3 days, and almost one entire day is to teach how to configure the DCOM because it's a technology that could be very complex in order to make it work properly. So when you have the applications running on different computers, you need to configure this DCOM, right? So we have procedures, we have the user manuals, we teach this in the training. But this is basically the security in OPC Classic. In order to the OPC client to be able to connect to the OPC server, they need to run with the same Windows user. They need to have, the user needs to be created in both computers. You need to take some steps into consideration in order to make this communication work when they are running on different computers. So at the beginning, when the OPC technology was created, like this was not so common, right? Like communicate an OPC server with an OPC client running on different computers, or probably not in the same net, probably they were in the same network. But nowadays, it's very common to communicate an OPC server with an OPC client, but running on different networks. So we will see that the DCOM has some limitations. One limitation that the DCOM has is the firewalls. That we say that, or if you read documentation, it says that the DCOM is not compatible with firewalls. The reason of why the DCOM is not compatible with firewalls is because the DCOM uses random ports. All right. Every time an OPC client tries to connect to an OPC server, the DCOM selects a random port. It could be between the 1024 and 65,535. Every time it tries to connect, if you reboot the computer, it will select a different port. That's why it's impossible to know which is the port the DCOM is going to use in that moment. That's why you say that the DCOM is not compatible with firewalls. It's not like they use many ports. It uses only one port. But every time the communication is done, if you reboot one of the PCs, it will select a dynamic port. It will select a random port. So if you want to have the communication running through DCOM, you cannot have any firewall, because probably this is something that happens to us a lot in the technical support department. The customers complain, oh, but I had this communication running for many months, but I had to reboot the computer because I installed the Windows updates and whatever. But then when you reboot the computer, the DCOM selected another port, and that port was probably blocked in the firewall. So that's why it's impossible to make it work with firewalls. This is basically a limitation of the OPC Classic because of the DCOM. Okay, so this is the conclusion. There is another reason or something. This is a very old technology from Microsoft, and of course, Microsoft constantly are developing new Windows patches, and they discovered back in 2021, they discovered a vulnerability in the DCOM. Okay, so they made some changes in the new operating systems, and in the new Windows patches, they made some changes. This change is called, if you look it into internet, it's called DCOM hardening. Basically, they discovered a vulnerability, and they implemented a patch that was rolled out in 3 phases, all right? It was optional in 2021, optional in 2022, but mandatory since 2023, okay? So basically, if you have DCOM communications running and you install a Windows patch, probably you might be affected with this, because they made some changes. Just to go more specifically, we have a document in our website which explains in very high detail of what they found. But basically, now the DCOM will need a different authentication level. When you configure the DCOM, in the DCOM configuration, you need to select an authentication level. So now it will, instead of support the authentication level connect, it will require an authentication level called less than packet integrity, right? And not all the applications in the moment they were developed, the OPC servers and the OPC client, they support this authentication level. That's why if you implement Windows patches in DCOM communications, probably the communication will stop working after you install the Windows patch because of this DCOM hardening. Okay, perfect. So DCOM hardening, from now on, the communication has to meet the new minimum authentication level, packet integrity. This affects only the DCOM, not the local communications. If you have your OPC server and client running on the same computer, you won't be affected. Okay, and these are the Windows versions that are affected by the DCOM hardening. Right, so this is only important if you have some DCOM communication running for years and you are planning to implement some Windows patches. All right, so because all these things, all these limitations of the OPC Classic and the limitations of the DCOM, We know that nowadays that we need to implement secure architectures with firewalls in the middle. And this is the reason why the MatrikonOPC Tunneller exists. It's actually the software in Matrikon that we sell the most. It's a software that allows you to communicate or to overcome the DCOM, because allows you to communicate an OPC Classic server with an OPC Classic client without configuring the DCOM. All right, the way it works is, as you can see in this picture, we install one tunneler in the server side, we install another tunneler in the client side, and then the tunneler, they communicate each other to a TCP/IP connection using one single port. And the port, you can select the port. All right, so we say that the tunneler is compatible with firewalls. It needs only one port, but you can select which is the port it's going to use. So basically what the tunneler does is, when you install the software in both computers, you create a connection from the classic client to the classic server, and automatically all the OPC servers that you have in the remote machine, you will have it in the client machine as you had it in local. All right, this is what we are going to do in the demo. Actually, you will be able to see how to connect an OPC Classic server with an OPC Classic client through the tunneler. You will see that it's very simple. You just need to have the port open in the firewall, of course, to be able to make a ping from the client computer to the server computer, like to have connection, not to make a ping, but to have connection. And my colleague Pedro will show you how to do it. Right? First, we will try with the DCOM, and then we will try to do it with the tunneler. Yeah, so this will be the demo. Basically, we have two computers. We are talking here about OPC Classic. We will talk like in a few minutes about OPC UA, but so far we are talking about OPC Classic. So we have two computers. We have the computer below with two OPC servers running. One is a simulation server. The other one is an OPC server that reads data from Modbus protocol. These two OPC servers are running in the server computer, and we want to communicate them with an OPC client, which is called MatrikonOPC DA Explorer, which is running in another computer. So first, we will try to do it with the DCOM, and then we will try with the tunneler. So the software, the tunneler is already installed. All these two applications are already installed. So let's show you how to configure in a proper way tunneler connection between classic servers and classic clients. Perfect. Pedro, can you help me with this? Can you, if you want to share the virtual machines?
Yeah, yes, of course. Thank you, Fernando. Thank you for the great explanation about the OPC technology. Okay. So, well, my name is Pedro. I am going to help my colleague Fernando to show you the demo about the software. Okay. So, well, I have here a couple of computers. I have two virtual computers. Okay. The computers that we see here in this diagram. Okay. So I'm going to the computer 215. That is the computer where we have our data sources. Our data sources are going to be the OPC Classic Simulation Server and the OPC server for Modbus, okay? So I am going to get inside that computer. Is this one. You can see the IP address here, okay? And here I already have this Modbus device. I already configured the OPC server for Modbus, and here I have the OPC Explorer. This is an OPC DA classic client of Matrikon that we use a lot for testing, okay? So here, everything with the Explorer, we can see all the servers that we have in our computer in localhost, okay? So now I just have the OPC server for Modbus and the simulation server of Matrikon. I'm going to connect to both of them, okay? Everything is in local, so I don't have this issue with the DCOM because the user of Windows are the same for the client and for the server that are running these applications, okay? So I already connect to the OPC server from Modbus, and here inside this OPC server, I have a couple of, I create some tags, okay? I put it in a folder called Modbus device, and I have the three tags, the level, pressure, and temperature, okay? So let me drag and drop these three tags. I am going to add it. And as you can see here, I am just seeing the information related to these three tags. As Fernando says, let me check. Okay, I am reading the information of these three tags, and then I am going to connect to the simulation, to the MatrikonOPC simulation. Okay, I am going to add more tags about this OPC server. Let me check. I have here the randoms. I am going to drag and drop a Boolean and also an integer. Okay, and I have here the information changing. So well, as you can see here, everything is in local, and I can connect to both of them without any issue. Okay. So now what we are going to do, I am going to switch to the other computer.
In the meantime, Pedro, just for you to know, this for the people in the webinar to know, this MatrikonOPC Explorer is a very useful tool for testing. All right, if you have OPC classic servers, we are doing the demo with MatrikonOPC servers, but either if you have an OPC server from any vendor and you want to test the communication, so far we did the test in the server computer where we had the two OPC servers. You can open the MatrikonOPC Explorer, it's free, and connect to your OPC server. And we use it a lot in the technical support department just to detect that everything is running fine. So if everything runs fine with the MatrikonOPC Explorer, then you can test with the real OPC client. So as Pedro said, now we will try the connection instead of using COM, because so far we have used COM. We have tested a local connection. Now we will do it from the other computer.
Yeah, that's correct. So what we have here, we are in the server side. We have our Modbus tags and our simulated tags from the simulation server. So now we are going to move to the computer where we have also the Explorer from Matrikon. That is the free tool, okay? And now we have here locally other OPC server, just the simulation. We don't have any other OPC server. And then we are trying to connect to the OPC servers that we have in the remote computer. Right now we are in this IP address, the 213, and we are trying to make a connection to the other computer. I'm going to put here the IP address of the computer where I have the Modbus server and the simulation server. And now I'm going to try to connect to the MatrikonOPC simulation server, okay? When I do this, here we get the DCOM issue. This is the classic DCOM error when we try to connect an OPC client with OPC servers that are in different computers, and we don't have like the right permissions in Windows to make this connection, okay? If we go to the details, well, we can find here that this client cannot co-create the instance, okay, to make this connection, okay? So, well, this is, as Fernando says, we have a training of 3 days to talk about the OPC technology, and we almost spent just 1 day to teaching how to configure the DCOM, okay? So, what we are going to do now, I move back to my diagram, and now we are going to configure this tunneler to read data from this other tunneler, and now connect the OPC DA Explorer to this tunneler, and we are going to be able to read data from Modbus and from the simulation, okay? So I am again in the computer where I got the DCOM issue, the DCOM error, okay? And now I am going to open the interface of the tunneler, okay? So this is very important. Now in the tunneler, when we are going to make a classic client to a classic server connection, when you install the software tunneler, you have both components in the software. You have the server side and we have the client side, okay? I am going to show you in this same interface, the server side. This is what we need to configure in the other computer, but I am going to show you here. to make it simple, okay? Just to let you know, we can add encryption, we can make user impersonation, and also we can restrict access to OPC servers. We can define like a list of what OPC server we are going to move through the tunneler, okay? Then if I go here to advanced, here, this is the default port that is used by the server side of the tunneler. But if you need it, you can change this port. This is the port that you need to open in your firewall to establish the communication between tunnelers, okay? So now you don't have this issue with the DCOM that you are going to use random port, because with the tunneler, you only will be using the port that you define in this field, okay? So, well, this is like the server side, and now as I am in the computer where I have the OPC Explorer, I am going to expand this, the client side gateway, and here I am going to add the connection to the remote computer. So here I need to put the IP address of the remote computer is the 215, and the port by default is this one. In case we lose the communication, I will select this option to retry forever to establish the communication. And once I put here the IP address and the port, now I click here in OK. And now this client side has a connection to this computer where I have a tunneler with the server side, and I have these 5 OPC servers. Why I have these 5 OPC servers? Because a couple of them are for the specification of PCDA, that is real time. Then the Modbus also support OPC alarms and events. And in the case of the simulation support HDA and also alarms and events. That is the reason why we have like 5 endpoints or 5 OPC servers, okay? So this is the in most of the cases, if we are not adding security or we are not adding, encryption to the communication, we only need to configure like the client side, because the server side, we don't need, if we are not adding security, we don't need to configure anything, okay? And then this, I already have this connection created, and then I am going back to my Explorer, and when click right now here in localhost, and I refresh all the OPC servers that I have in localhost, we will find here that now, additional to the MatrikonOPC simulation, I have these 5 local OPC servers. So if I connect, for example, to the Modbus, okay, and try to add some tags, I go here to my aliases, Modbus device, and I can read right now the tags that are coming from the OPC server from Modbus in the other computer, okay? I have here my 3 tags with the path of the tag, the value, the quality, and the timestamp. And the same for the simulation. If I connect to the simulation, try to add some tags, okay? For example, this random that is changing, an integer that is changing, and also a Boolean, okay? And I have here these 2 tags, okay? So, well, this is basically what the tunneler in the regular functionality does, okay? And this is what we try to explain in this diagram, okay?
Exactly. So thank you, Pedro. Keep it like this. Let me, well, just review. So we had the classic servers in one computer, the classic client in another computer. We tried the connection with DCOM. This usually when we do the trainings, there are 2 types of people: the people who have dealt with DCOM and the DCOM headaches, and they value a lot this, because they know probably they spend hours trying to configure DCOM, and with the tunneler you can make it work in a few minutes, just like we did. And the people who hasn't dealt with the DCOM, they say, okay, sounds like a good tool, but it saves you a lot of time of DCOM configuration, right? But Once you understand the concept, once you understand you cannot have any firewalls, with the tunneler, something that the customers like is that they can select the port. So even the IT people can tell you which is the port, and you just go to the tunneler and use the port the IT people told you. All right. So again, talking about OPC Classic, DCOM issues are solved with the classic functionality of tunneler. This is the functionality that has been running for many years, but we want now again to show you like the new functionalities of the tunneler. Right, let's go back to the presentation. As I said, OPC Classic was created in 1995, but because of all these limitations we mentioned, we know nowadays with the IoT era that now it's very common, or is actually mandatory, to communicate OPC applications running on different networks through internet. So of course, this technology, the OPC Classic, is not compatible with that, to move data across internet in a secure way. So that's why the OPC technology or the OPC Foundation created the evolution of the OPC Classic, which is the OPC UA. Okay, go to the next one. Let's review just quickly of course, there are many differences between the technologies. The purpose of the technology is the same, to communicate devices, PLCs, DCSs, RTUs, any industrial data source, to communicate them without taking care which is the vendor with those software applications, SCADA, CRPs, MES, databases, and so on. The purpose of the technology is the same. The thing is, it's a different technology. So there are many differences. The main one, I could say that the main one is that now the OPC or the OPC UA, it didn't use the DCOM to communicate the two software applications. It created their own stack of communication. So in OPC UA, when you communicate an OPC UA server with an OPC UA client, you are not using DCOM or COM anymore. We are not using the technology of Microsoft. This is the reason of why we can see OPC UA applications running in Windows, in operating systems different than Windows. Okay, we can see them in Linux, we can see them embedded in hardware. All right, this is the reason, because the OPC UA is not tied to Windows anymore. So the security in OPC Classic was based on the Windows user. In this case, the security in OPC UA, as it's not based on the DCOM and COM technology anymore, it's based on digital certificates. You exchange digital certificates between the OPC server and the OPC client. The communication, of course, is encrypted. It's more robust. It's a technology that is way more new than the OPC Classic, which is why allows you to move largest amount of data compared with the OPC Classic. And as the OPC Classic support redundancy and so on. So those are like the main differences. Of course, also we teach this in a training. There are many more. But let's go to the next one, Pedro, please. And because we want to mention that now what we can see in the industry, what we see a lot of hybrid architectures. Of course, as you know, in the industry, you cannot replace everything from one day to the other. It's not like in IT that you have one version of one application and you roll out a patch, and then in one day you have another application running. When we are talking about OT systems, we have systems running for 10, 20, 30 years. So we cannot replace everything what we have in OT. So what we see now a lot is we still see OPC Classic infrastructure, but we see a lot of hybrid architectures. Architecture which has in one end OPC UA and in the other end OPC Classic. So this is what the tunneler also solves nowadays with these two extra functionalities. Also, this is important because probably you have a classic tunneler, and now one of these functionalities that supports OPC UA is useful for you. You can know now that these functionalities are also supported. All right. So basically, is to integrate hybrid architecture. So we will see the two cases that we have in the slide. So we already did the configuration of the regular tunneler, and now that we have the two below, the UA proxy and the UA wrapper. The UA proxy is that when you have an OPC UA server, probably a PLC, that they have an embedded OPC UA server, and the OPC classic client, like the SCADA, for example, you don't have an OPC UA client, it doesn't matter. You can either way connect with the OPC UA server because you use Tunneller only in one end. So the Tunneller basically works as a converter from OPC UA to OPC DA, and the other way around, which is the UA wrapper. All right. So if you have an OPC Classic server and your SCADA already supports OPC UA client, you can convert easily your OPC Classic server into UA. And we will show you a demo of these two functionalities. So let's go to the next. All right. So first, what we are going to do is that we will convert an OPC Classic server into UA. All right. We talk with a lot of customers from different industries. It doesn't matter the industry, pharmaceutical, oil and gas, energy, food and beverage, all right? All of them, they have the same structures of, they have OPC Classic servers running, and probably the application who is reading the data supports OPC UA. So in this case, with the Tunneller, we can convert any OPC Classic server into UA just by placing one Tunneller in the same computer where we have the OPC Classic server. So what we are going to do now, if you go to the this is the demo that Pedro will help me with the virtual machines. The same two OPC servers, the same two classic OPC servers that were running in the server computer, now we will convert them into UA. All right. Now in the client machine, instead of having an OPC Classic client, we will have an OPC UA client, which is called OPC UA Explorer. All right. As I say, with the Classic one, it's a free tool that you can use to connect with OPC servers, in this case to OPC UA servers. So what we are going to do is that, okay, what happens if my application, my SCADA supports OPC UA, but I need to connect with all OPC Classic servers? Okay, place a Tunneller in the server side, convert them into UA, and now you will be able to read the data. And this is what Pedro will show you right now.
Yeah, thank you, Fernando. That's correct. So, well, let's move again to this computer, to the 215. Okay, I have it here. Okay. Now I am going to open. Well, I already opened the interface of the software Tunneller. Okay. Here we have the two options that we use for the regular communication. And when you install now the software, you have these three tabs on top. If we move to the UA client to Classic server, here we can add as many local OPCDA server as we have in the computer. So for example, I already add the Matrikon simulation and also the OPC server for Modbus. But if you click here in the add button, okay, we are going to look for all the OPCDA server that we have running locally in this computer. Okay. Well, in this case, for example, we find two for the Modbus and two for the simulation because it supports two versions of the OPC standard. Okay. What else? Once you add the server here, okay. Here you will find like the URL that you need to put in the OPC UA client to connect to this OPC UA server. So this is like the regular syntax, opc.tcp, then you can have like the name of the machine or the IP address of the computer, of the local computer, and then the port that is used by this OPC UA server, okay? What else can I show you? If we go here, for example, to server security policies, okay? For this OPC UA server that we have here, that is the wrapper, we can add different security policies, and also we can add different user policies. So to make it easier in this webinar, okay, we are going to use I have different options. Well, we are going to use the none and also the anonymous from the OPC UA client to try to connect, okay? So, well, right now, this OPC UA server is running, as you can see here. And I am going to switch to the other computer. Right now, I am in the 215. I am going to switch to the other computer, this one, the 213, where I have, for example, my SCADA application, or in this case, the OPC UA Explorer, that is the software from Matricon to test OPC UA servers. So I am going to open this application here. I have it here. Okay. And now I am going to add like a new connection. So I need to define the IP address where I have the OPC UA server. In this case, going to be the IP address of the other computer, the 215. And then in the port by default, okay, the port is the 21381. Okay. When I click here in search, I discovered I find the OPC UA wrapper, the OPC UA server, and when I expand this, I find like the different endpoints of this OPC UA server. So as I mentioned before, to make it easier, we are going to connect with non-security, okay, and then with the user anonymous, okay. So when I click here in connect, now I can see in the address space of this OPC UA server a couple of folders. I have a folder for each OPC UA server that I previously add in the wrapper configuration. Okay, so yeah, if I expand this in the Modbus, I will find the configure aliases, the Modbus device folder, and I have my 3 tags: the level, the pressure, and the temperature. That these 3 tags are coming from the Modbus device. I have my tags here with the timestamp, okay? I can also, for example, add information from the simulation. Okay, so if I go here to simulation items, I go here to random, I can add a boolean, an integer, an array of string. I can see everything here. Okay?
Okay, thank you, Pedro. So
Okay.
something that is amazing about
Mhm.
about this conversion to OPC UA is that, as you can see in this UA client, you don't need to add manually the tag. You can make a browse. So if you have an OPC Classic server with the information with the tag, you place the tunneler, convert to UA, and then you just drag and drop the tags. You don't need to add them manually or anything. If you have a folder with 10,000 tags, you drag and drop the folder, and all the data that you are exposing over OPC DA, you can do it over OPC UA.
Yeah,
Thank you, Pedro.
and additional, these applications allows you to export all the address space that you have here. If you click here, you can export this address space into a XML file, and you
Exactly.
can
This is
work with
very
them.
useful. It's very useful because you can add all the tags here, and then you can export the configuration. You will have all the tag lists that probably could be useful for your OPC, your real OPC UA client, to like the SCADA and so on, to add the tags. Perfect.
Okay.
So summarizing, we did that. We converted the OPC classic servers into UA by placing the tunneler. This is very important in the same computer where you have the OPC classic servers, because we don't want to have issues with DCOM. That's why we need to put the tunneler in the same computer. The communication between the tunneler and the OPC's classic servers is in local, so we are using the COM. Perfect. Now we will do the other, because this is the last demo, and then we will answer your questions. What happens the other way around? My OPC Classic application, the client, like the SCADA, is supporting only OPC Classic, but the device or the data source is OPC UA. This is the typical case of a new PLC that has an OPC UA server, or IoT device that has an OPC UA server, and I want to integrate them with my OPC Classic client. So now we will place the tunneler in the other end. Go to the next one. Yep. We will place the tunneler in the other end. So we will use a software called Venom, which has an OPC UA server. This software has some data, some simulated data running. So we will learn with the tunneler how we can address or how we can connect to OPC UA servers using an OPC Classic client. So in this case, we are not using the UA client, we are using, again, the MatrikonOPC DA Explorer, the classic one. We will use the tunneler to connect to that OPC UA server and convert it into DA.
Okay, perfect. Thank you, Fernando. So well, I'm going back to the virtual computer that we are using as our data source, okay? And here, let me show you very quick, okay? Here I have this Vino software, okay? Let me just see that the software is running. If I go here to real time, I have some OPC UA data, okay? This is 3 tags that I have here, the power, the RPM, and the speed, okay? 3 tags. And then I have here a module that is an OPC UA server, okay? This is the network interface that we are going to use in this computer to receive incoming connections, okay? And this is the port that we are going to use where this OPC UA server will be listening, for a new connection, okay? Also, we can add here like different endpoints and also to allow anonymous user, okay? This is just to show you very quick how to do this, and we want to do it in the easiest way, okay? So right now, this OPC UA server is running, as you can see here, and is serving data, is serving these 3 tags. So then let me go back to the other computer, the computer that we are using as a client, okay? And here I need to open again the tunneler, and I need to move to this second tab, that is the classic client to the UA server, okay? Now I need to add the URL of the OPC UA server. So I need to put here the IP address of the OPC UA server. Is going to be this one. And the port, if you remember, is the 3005. Okay, that is port that is used by Vino. Okay, if I click here in add, I will find the OPC UA server. Okay. And if I try to connect, I have 2 endpoints defined in this OPC UA server, the none and this one with encryption, okay? I am going to use without security. I am going to use the user anonymous. If I create this, okay? Now the tunneler is going to create a local services for this OPC DA server. As the software needs to create this local service of Windows, we need to put here the user Windows credentials. This user of Windows needs to have administrator rights in order to be able to create this service, okay? I put this is the user. I put here the password. And now I have, this is like of this local OPC DA server that is just converting this OPC UA server that I have in the other computer. That is the OPC UA server of Vino, okay? So if I open again the Explorer, you know, where we connect through the Tunneler DA, okay? I can disconnect this, and I also can disconnect this. And I make a refresh of all the OPC DA that I have in local, we are going to find a new one. That is this one, UA proxy. You can see it here. So if I try to connect to this OPC UA server, right now this OPC DA server is running, and I try to add some tags, okay? And I will find the OPC UA device, and inside I have my 3 tags that I already defined in Vino, okay? We have the power tag, the RPM tag, and the speed tag. I'm going to add it, okay? And I have there my 3 tags with a classic OPC client, okay?
Yeah, if you can go back to the presentation, Pedro.
Yes,
Thank you
of
very
course.
much. This was the last demo because we are
We
on
are,
time already.
yeah.
Yeah. We got a couple of questions that I already solved through the chat. Babak say that well, asked us if the is a signal structure of in the OPC UA when we did the demo of the wrapper, if it should follow the OPC classic naming with the tunneler, yes, but we have another software that allows you to create your own tag structure. Also, I have another question, which is regarding the number of connections. This is something that I didn't say.
Yeah, very important.
Tunneler, yeah, the tunneler has no limit in connections. All right, you can have as many. The connection of tunneler could be many to many. You can have one tunneler connected to 5 different tunnelers, which has each of them has an OPC classic client. Okay, so the connection of tunneler is many to many, and the price of the license is not related to number of connection, and it's not related to the amount of tax.
Yeah.
Okay, and another question is the MatrikonOPC UA wrapper hard coded for the open URE. Like you can modify that URE by modifying the XML file of the configuration. What else? UA server to EA client doesn't not need tunneler. David is asking. Yeah, exactly. You don't need the tunneler with if you are talking about a pure UA to UA connection. So what you need is to open one port in the firewall. Matrikon has another software for these cases, which is called MatrikonOPC Data Broker, that allows you to be installed in both ends, in the server side and in the client side. And what allows you is to use a functionality called reverse connection. Because now what the customers are looking for is when they communicate OT applications with IT application is not to open inbound ports in the firewall. So if you have a pure UA to UA connection, by using this software data broker, you can take a look into the website, you can block all the inbound ports in the firewall. You just need to open a port in the other direction, which is normally not a problem because all the cybersecurity threats are coming from the IT networks. All right. So if you have a pure UA to UA, you don't need tunneler for sure. In case you want to use the reverse connection functionality in order to not open inbound ports in the firewall, you can use this data broker.
David, keep in mind that sometimes, for example, we have working in projects where maybe the customer want to add security per user in the OPC UA server, and the OPC UA server that they have, they don't support that. So we can put in the middle also the data broker to add the security, for example, per user to access the data from the data source. So it depends on the requirements.
Right. Another question from Luca. How does it work licenses for Tunnel Classic or UA? Now, when you buy a tunneler, includes the DA functionality and the UA. So either you can use it to a classic to classic, or you can use it to a classic to UA. All the tunnelers we sell since 4 years ago includes both functionalities. So you can decide if you want to use it to convert it to UA, you can do it, or actually you can do both. You can connect classic to classic with one computer and also convert to UA with another UA client. So the license, the basic license of tunneler already includes both functionalities, classic and UA.
Perfect.
Welcome.
Okay.
Anything else? Any further question? Oh, okay. This is important. Yeah, this is here you have our emails from me and Pedro. Okay, we are based in Spain, in Barcelona. So if you have any question, if you want to use any of the software, this is something very important. All the software is available for testing. Like if you want to, you don't need to buy a software without seeing the software running. Okay, if you have an OPC Classic server and you want to convert it into UA, you can use the trial license, make it work for 30 days, show it internally to your boss, make a presentation internally, and then decide if you want to purchase the software or not. All right, all the software is available for testing. You can send us an email and we can actually give you a help with the software configuration. right? This is very important because you don't need to buy anything in advance. You can test it first and then decide if you want to use it or not. Okay, so here you have our emails. This is
There is
important,
some
Luca, also.
other question.
Yeah, Luca is asking if it's possible to have this webinar presentation and the recording. Yes, we will share the recording of the webinar, and the presentation we can share it in PDF. Luca, if you can send us an email, I will share with you the presentation in PDF format. And regarding the recording, all of you who have attended the webinar will receive the recording.
Okay. I think that we are done. Yes.
I think. Okay. Well, thank you very much, everyone. Thank you, David. Thank you, everyone. Very quickly, we have also as I said at the beginning, we provide trainings about different topics in the industry, about OPC Classic and OPC UA. We have a training about cybersecurity. We have a training about industrial protocols like Modbus, EMP3, IC104. So basically, we have another training for IoT. So as you will read the recording, if you have any interest of joining these trainings, some of them are online, some of them are in place, like normally in Spain. Feel free to send us an email. Okay, yeah. I will look. I'm reading your email. I will send it to you the presentation. All right. Thank you very much. Thank you, Babak, as well. And thank you, everyone.
Thank you, guys. Bye-bye.